Okay, in this lesson, we're going to use a little bit of geometry, a little bit of algebra to answer some questions that are going to help you next year in calculus. So, if you look at this looks like a right triangle within a right triangle, so Pythagorean Theorem should be on your mind. Also, we have similar triangles, so we've got some ratios. So when the directions say express x in terms of the other variables, our final answer should be x equals, and then something, and there should not be an x over here. So let me kind of explain to you something that could happen that would not be good. Like if we had x in two different places and we set up a ratio and it said x equals blah blah blah, and there was x in there, and we didn't do our job. Okay, so if you look at this, there's a couple of missing things. All right, like I can see that t is the big base, h is the big hypotenuse, but we are missing the height here. Now I could find the height of this big triangle, but I would need x to find it. So I'm thinking I don't really care to do that side. What I really want to know is what is this missing side right here. All right, and so if we look at this right triangle, let's use what we know about Pythagorean theorem to come up with an expression here. We know that h squared plus whatever goes right here, and we could call it a variable or whatever, that thing squared should equal the hypotenuse, which they're calling r in this case. Okay, so what would just that question mark be? Again, we could have used a letter here, that's fine, whatever. Okay, it would be r squared minus h squared, and then we'd need to square root that whole thing. So now I have this base of the smaller right triangle in terms of r and h, which is good. It's not in terms of x. That would have been a bad thing because I don't want x in my answer. I want x to equal something with h, r, and possibly t. So if we think about the big base over the hypotenuse, okay, then I could maybe start off my proportion like this, x over t. Now, it doesn't matter how you start it, what matters is that you stay consistent. So I did big hypotenuse over big base. So now I got to go little hypotenuse, which is r, over little base, which is this thing that we found right here. So it would have been nice if we had not had to do that, but I did. Now, getting x by itself with all these letters is the same way you do it if it was numbers. First, we're going to cross multiply x times the square root of r squared minus h squared. And I hadn't mentioned this yet. You cannot simplify this. If you're thinking, that's r minus h, first of all, it's not. Second of all, you're not required to simplify in this, so it wouldn't even be worth your time to do that. And that's going to equal t times r, or r times t. I'll go ahead and put them in alphabetical order. And then you would divide. If this was numbers, you do cross multiply and then divide. Again, this really may bother you that there's so many letters, but that's okay. Just get over it, I guess. So here we have x equals r times t over the square root of r squared minus h squared. We have expressed x in terms of the other variables. Notice that there is no x over here. Okay, that's it. Okay, later on, like, why do we do that? What do we do that with? That's what you do later on in calculus. For now, this is what we're just practicing the skill. Okay, if you notice something that's missing in example 2, it's the picture. All right, so I'm going to draw the picture as we go. It says we have a wire, and that is 24 centimeters long. And it's cut into 2 pieces, so I'm going to put the cut right here. I don't know which side is bigger. It's just to help me set this up. One piece of the wire forms a square. So I'm going to say that this piece of the wire forms a square. The other is bent to form a rectangle. Again, I don't know if this is exactly what it looks like. Okay, I'm just drawing the picture to help me as we go. Okay, here we get into some good information. The rectangle, which is 3 times as long as it is wide. So if we have the width here, then they're telling us that the length is 3 times the width. All right, and this is important because we're going to want to put this all in one variable later on, and it'll tell us which one. It says write an expression for the sum of the areas of the square and the rectangle. So I need to do the area of the square plus, for sum, the area of the rectangle. And it's going to tell you this needs to be in terms of width. So my final answer can only have W in it. Okay, so let's start with the side that's a little bit easier. All right, so first of all, I have a W here, I have a W here, and then I have 3W here. Okay, I'm just kind of covering all my bases here. And then I'm going to get rid of L because I only want W. So how would I find area here? I would multiply W times 3W, and if you want to call that, whoops, if you want to call that 3W squared, you can. I'm going to leave it unsimplified though. All right, so now I need to do the same thing over here with the square, and I'm going to switch colors, okay? So because now I've got to somehow use this 24. All right, so let's think about perimeter. We're not finding perimeter, but if you think about the wire, it is the perimeter. So we have W, 3W, W, 3W. How many total W's is that? Okay, 1 plus 3 plus 1 plus 3. That's going to be 8W. Okay, so this piece of the wire, okay, is 8W long. So the other piece, we're working backwards here, is going to be 24 minus 8W. 24 was the total length of the wire. If we subtract out 8W, that's what we have here. That's this square's perimeter. So how would I find just one missing side? All right, there are 4 sides. Like if I called this X and this X and this X and this X, the perimeter would be 4X. Well, the perimeter, again, not finding it, but using it to help me here, is 24 minus 8W. So if I take that, and I'm going to kind of go over here, if I take this 24 minus 8W and I divide it by 4, that should give me just one of the sides. And I'm just using X here. We could have not introduced that number. You don't have to simplify. You can leave it just like this. 24 minus 8W all over 4. And that's it. That's your answer. It is not simplified. You're right. If you were required to simplify, you could go 24 over 4. That's a 6, and then that's a minus 2W. So there's one thing. This is X. How would I actually find the area, though? I need to do one thing to this. I need to square it. Okay? Because the area would be X squared. All right? So if this is all bothering you and you wanted to simplify it, knock yourself out. Not required. Moving on. This is a pretty typical problem in calculus, and again, you're going to get to see like when you actually use this. It has to do with like maximizing or minimizing your work or your time or your distance or whatever. That's when we use most of the stuff. So it says Laura was riding in her motorboat on Lake Lavon when she ran out of gas and she discovered she had left her cell phone in her car. The boat was 4 miles from the nearest point on a straight shoreline, which is 6 miles from a beachfront restaurant. So they label the picture for you nice. Well, let's go ahead and put in a right angle here. It says Laura decided to row the boat X kilometers to the point on the beach and then walk to the restaurant. So why would she take this path? Well, it may be that if she kind of just went the nearest way, it would take too long. Or if she rode the whole way there, it also might take too long because it may take her longer to row than it would to walk. So there's a sweet spot in the middle. That's where we eventually go with this. That's why the picture's set up this way. All right, and so all they're asking us to do on this problem, though, is to write an expression for the total distance she will travel in terms of X. Okay, so let's think about the distance that she's going to row. Okay, and that's the easier one. And then let's do the distance that she's going to walk. Now remember, our answer should have only X. Only X. So how far is she rowing? Right here. That's X. Okay, so the real work here is figuring out the distance that she's going to walk. What is that distance right there? Okay, this is kind of we're going to work our way around to it. Okay, if you just look at the triangle, this is like we did in the first one. Let's first find this thing right here. And if you want to call it a letter, you can. If you want to call it a question mark, you can. It's just there to help you get to the end. So 4 squared plus question mark squared equals X squared. If you want to call this A, call it A. Doesn't matter. Okay, in the end, you got to solve for it. So if A squared would be X squared minus 4 squared, and you want to call that 16, great. And then you would square root it. This is not X minus 4. It does not simplify like that, and you don't have to do that anyway. Even if it did simplify, I probably wouldn't do it. but it doesn't, it's not x minus 4. Okay, so that's A. So now we're going to switch over here and maybe we could call this B. So if we know that A is this expression and we know that A and B together make 6, well then what would B equal? It'd be 6 minus this thing. Okay, and so that's what we're going to put right here. 6, whoops, I almost wrote a plus. Not a plus, a minus. So again, we use Pythagorean there. That's going to come up a lot. Okay, none of this simplifies, by the way, but even if it did, you wouldn't be required to do it. So we're going to box it and we're going to move on. Okay? Probably we should put miles here. Let's see if we left off the units in the last one. 1 in units on number 1. We should probably put units here. So what would the units be? Centimeters for area squared. Okay, good. Let's do one more problem. They give us a picture, that's kind of good. Then they explain it. 2 vertical poles are 20 meters apart. Okay, so here's a pole right here, and then here's a longer pole, taller pole here, 20 meters apart. From the top of the shorter pole, which is 5 meters tall, and they label that 5 here, to the top of the longer pole, we got W meters long. All right, and what you can assume here is that that's a right triangle. We can assume that because of the ground and vertical things being perpendicular. It says the height of the taller pole is X meters, and they label that there. It says find W in terms of X. So I'm kind of going back to what we did on number 1. My final answer should be W equals blah, 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 and there should only be an X in numbers, but there shouldn't be any other letters over here. Okay, so we want to put other things in terms of X. Okay, so let's think about how, first of all, if we knew what X equaled, how would we do this problem? If I knew that X was, say, 7, okay, this down here would be 5, and then we could say this was 2, and then we could do Pythagorean Theorem. So I'm going to use that. All right, if this down here is 5, let me switch colors here. Then this up here would be 5 minus X. Or, sorry, oops. Oof, you can tell I'm getting tired today. All right, but I caught it, so that's all that really matters, I guess, right? The total is X, so I'm finding this right here. The total is X minus the part, which is 5. You always want to do total minus part here. All right, so then now we're going to focus on Pythagorean Theorem and this triangle right here. Okay, the only thing that you really got to be concerned about is what is the hypotenuse. Okay, these two sides, it does not matter the order that they go in. 20 squared plus X minus 5 squared, that's going to equal W squared. Now remember, we're trying to get W by itself, so we would just square root. Now, something that you might have thought of earlier is why are we not doing plus minus? Well, in a real life situation, could an actual distance be negative? No. So that's why we're not doing plus minus here. And it looks like we do got units. It's just going to be meters because we're talking about a distance. If we were doing area, we do meters squared. And so that's kind of how you work these problems. You've got Pythagorean Theorem in your toolkit. You've got this whole, when you're the longer distance minus the shorter distance. You've got proportions and ratios, and you've got setting up different variables. And that's how you're going to kind of approach the rest of these problems. You're not going to see 4 exact similar problems to this. You're going to have to think about them. All right, so don't give up easily. There's not that many of them to do, and try all of them.